So surface area and volume of a cone, this is lesson 5. A cone is a three-dimensional object with a circular base and a curved lateral surface which comes up to a point called the vertex. So the vertex is the point at the very top here. The height here is the perpendicular height compared to the radius at the bottom, or the diameter. So the height is always from the vertex right down to the center of the circle. But then there's something also called the slant height, and usually we use an S for that. And that is on the lateral side, and it goes from the vertex down to a point on the edge of the circle. So height and radius and slant height. First, surface area. If we look at the surface area of a cone, this formula here is on your formula sheet. So we notice there's a pi and an r. So r is the radius of the cone, and then s is the slant height out here. So that's for the lateral surface of the cone, plus pi r squared. The pi r squared is for the circular base of the cone. So if we add those two surface areas up, we would get the total surface area of a cone. So example 1, a pretty typical example might be to find the surface area of this cone, but you know that if we're going to use this formula here, we need to know the slant height. The surface area formula doesn't actually include the perpendicular height here of the cone. We need the slant height and we need the radius. So what you might notice right away, if I'm going to need the radius in two areas of that formula, I need to find the radius down here. So it might happen that you would have to use the Pythagorean theorem. So there's a lot of cases, whether it's a square-based pyramid or something like that, where the Pythagorean theorem might be very useful in order to find one of the missing dimensions. So if we just imagine this triangle, if pulling that triangle out of the cone, it would look like this one over here, and we're trying to find out what the radius is. So don't forget, if the 8 is across from the 90-degree corner, and the corner is kind of pointing at the 8, then this would be our side C, or that would be our hypotenuse. That has to go in for C over here. And then with the Pythagorean theorem, A and B, it doesn't really matter which one is which. If we say that maybe the A is actually the R and the B is the 4, or we could have said that this was 4 and the B was an R. So 8 times 8 is 64, and 4 times 4 is 16. And I think you remember this is one of those where we're going to have to subtract. So 64 minus 16 is going to equal r squared, and that's 48. But that's r squared, so we want to take the square root of both sides. So we end up with 6.93 centimeters is the radius. Try and use at least one decimal places. This 6.9 would have been great. 6.93 is even better. Try not to round that right off to 7. It's nice to see at least one decimal place. So now we know now we know the radius of the cone is 6.93 centimeters. So we can go back to our formula for surface area, or just A or SA, equals pi rs plus pi r squared. And then we just sub in the values that we know. So pi, if you're using your pi button on your calculator, the radius is 6.93 times the slant height is 8, plus pi times the radius squared, 6.93 squared. And that represents the circular base at the bottom. So we'd multiply these three numbers together, and I would get 174.17. And then pi times 6.93 times 6.93. Remember, it's just the 6.93 that is squared, so you might even want to do that first, and then multiply using your pi button if you have a scientific calculator. And I get 150.87. 325.04 centimeters squared would be the surface area for that cone. So a lot of this is just finding the right formula from the formula sheet, subbing in the correct numbers where they go, knowing that when variables are side by side that it's multiplication, following BEDMAS, and just making sure you have units in your answer. So it's a lot of just formula sheet use that we're learning. On the other page, this is talking about volume of a cone. So one thing is sort of similar to something we've seen before. If we filled these 3 cones with water and poured them into a cylinder that has the same size base and the same height, 3 cones would fit. 3 cones of water would fit perfectly inside of one cylinder. So if we're talking about volume on the inside of these shapes, it's interesting that we would have volume of a cylinder. So this one up here is pi r squared times height. So if we're talking about a cone, it's just the pi r squared times height, but divided by 3. So your formula sheet might show you a couple of different ways to write this. I'm a big fan of this one here, because really this means, and you'll see me write these lines a lot, this just means pi times r squared times height divided by 3. I'd rather just see that entire numerator all divided by 3. I think that looks a lot more simple. If you see 1/3, I don't think I'd use 0.33, but I guess you could. I would try and multiply all my numerator together and then divide by 3 afterwards. So example 2, last one, find the volume of the cone. So volume of a cone, all we need is our formula, which is the volume formula for a cylinder, and then we divide it by 3. So notice the diagram. Sometimes it's a little hard to tell. This 7, and then there's this line going all the way across. Try and really notice what that's trying to say. I think this side is probably 3.5 and this side is 3.5, because the line does go all the way across to make the diameter 7. So I think the radius is 3.5 centimeters. So over here, I'm going to use my pi button. The radius is 3.5 squared times the height of the cone, so the perpendicular straight up and down height, not the slant height on the outside. So the height of the cone is 6, and we divide by 3. So if you don't have a scientific calculator, I guess you'd type in 3.14 times 3.5 times 3.5 times 6 divided by 3. Remember that it's just the 3.5 that is squared. So in the numerator, when I multiply all those together, I got 230.91 divided by 3. So I ended up with 76.97 centimeters cubed for the volume.